Alright guys, I'm gonna start out here very pessimistically and say that this video might bomb, but I think I'm confident enough in my math skills I can make it work. We'll see. I didn't practice beforehand, so alright. We have this problem where we want to be able to solve quadratic equations because we're getting these vertical equations of motion, these vertical displacement equations, and they look like, 3x or like 20 plus 3x minus 4.9x squared. Instead of x's, it's t's, but we want to be able to solve them. And I just showed you on the last video, or maybe I showed you in one of our conferences, that it's not very easy to solve by, you can't do it by just isolation of variable, at least not very easily. And so I'm going to show you a method. This is actually one of the only, I shouldn't say that, it's one of the core methods of solving a quadratic equation. And it's quite clever. Basically, it starts with this, okay? So let's say I had x plus a squared. This is just some expression. This is a variable. X is going to be our variable. I know a looks like a variable since it's a letter, but it's actually some number. We don't know what number it is, but we're assuming that it is some number. It could be 4, it could be 8, but we're using a generic case because we work from generic to specific. If we solve generically, then specific is much easier. So here you have, x plus a squared is the same thing as x plus a times x plus a. Now you use FOIL, right? First, outer, inner, and last. So you multiply them, and then you add those all together. And of course, these are like terms because they both have something x. And again, we know what a is, just some number. So you have x squared plus 2ax plus a squared. Now, the key is, if we can write something so that it looks like this, x plus a squared, then we can solve, or so it looks like this. I'm sorry, let's go back. If we can write something that looks like this, even though that looks really ugly, if we can make something look like this, then we can change it to this, and once we have that, this is pretty easy to solve because you can take the square root, and then you'll finally be able to get x by itself. So here's what we have, and we want to make it look like this. Oh, I'm sorry, this should be equal to 0. Alright, first thing I'm going to do when I complete the square is I'm going to get rid of this last number here, because I just want to deal with this right here. So I'm going to subtract 5 from both sides. I'm going to have x squared minus 8x equals negative 5. Okay. Now, complete the square comes from the idea that if we start with this, right, we can kind of see x squared, that looks the same, and we're going to say that minus 8x is the same as 2ax. And we're going to solve for a, and then if we add a squared, once we know a squared, if we add a squared to both sides, of course, we will have x squared plus 2ax plus a squared. And then we can write it like this. So first thing I want to do is solve for a. Now I'm saying the first two terms, x squared and x squared, are obviously the same, so I don't have to do anything with those. But I'm going to figure out what a is by looking at this middle term. Now you have to include the negative here because you can think of it as plus negative 8x. So I'm saying that negative 8x is going to be equal to 2ax. I'm setting these two terms equal to figure out what a is. Okay, so you just solve for a. If I'm going to solve for a, let's say I want to get a by itself, let's say I divide it by x. And just simultaneously, I want to divide by 2 as well, because I really want to get a by itself. So let's divide by 2x. Okay, so this is pretty easy on this side, right? 2ax divided by 2x, the 2's cancel, the x's cancel. You just have a, which is exactly what we want. On the other side, you have 8x divided by 2. So negative 8 divided by 2 is negative 4, and x divided by x, they just cancel. So negative 4. In other words, we just solve for a. So this step is kind of weird, like the setup, but the actual solving for a is pretty easy. A is going to be negative 4. Okay, so I need to complete the square. That's where the name comes from. To complete the square, I need to add a squared. Well, if a is negative 4, a squared is 16. Negative 4 times negative 4 is positive 16. So I'm going to add 16 to both sides of the equation right now. All right, so here we go. X squared minus 8x plus 16 equals negative 5 plus 16. Let's address, let's simplify this side. Obviously, negative 5 plus 16 is just positive 11. But on this side, we have written this like that, right? And so we know that then we can transform this to right? There's a bunch of equal signs, but transitive property tells me all these things are equal to each other. So we can change this into x plus a times x plus a. In other words, x plus a squared, right? So this is the same as x plus, again, a is -4, or so. I could put plus -4, or I could just put x minus 4, and I'll just put x minus 4. X minus 4 squared. Okay, now you can finally get x by itself, because now I can take the square root of both sides. And don't forget, it is the square root of both sides, the square root of 11, square root of that. All right, so I have, first of all, the square root of this is pretty easy, just x minus 4, clearly. This is where it's a little bit tricky. 11, what if I take the, so we want to get the, we want to tell me, so we're taking the square root of 11. Basically, what number times itself would give me 11? There are actually two numbers, right? It could be the positive. So let me just do square root of 11 real quick on the calculator. So when I type in square root of 11 on my calculator, I get 3.3. We'll call it 3.32. There are actually two numbers that squared give me 11. It could be 3.32 or negative 3.32. So I'm going to put plus or minus 3.32. And then let's get x by itself. So now I just add 4 to both sides. Plus 4, and I have this. X is going to be equal to 4 plus or minus 3.32. Well, this plus or minus, you could actually leave the answer like this as far as I'm concerned, or you could even have left it as x is equal to 4 plus or minus radical 11 works too. But the actual solutions you could add or you could subtract. In fact, you do both. It's called plus or minus. Or in my opinion, it should be called plus and minus because it's both. You do both. So if I do 4 plus 3.32, I end up with x is equal to 7.32. Or, on the other hand, if I do 4 minus 3.32, I get 0.68. So these are the two solutions for x. Again, there's a reason why we have two solutions, because this this equation, if I graph it, x squared minus 8x plus 5, I'm just going to give you a very rough idea. It's going to look something like this. It's going to open up because this first term is positive, so it's going to be like a smiley face. That's how I remember it. Positive is like a smiley face. Alright, and besides that little blip there, it's basically going to look like this. So I'm asking, when is this equal to 0? Well, there's going to be 2 points right here. Well, maybe I should use a different color. Right here and right here. Okay, and clearly you see my picture's wrong because it actually should be shifted over a lot. And I think that comes from the 8x maybe, but it should be shifted over. So actually, you end up with 2 different points because if you shift over, yeah, anyways. You shift it over and you get 2 points. So they're on the 7.32. But anyways, the point is there are 2 points where it's 0, and that's the way it should be. Now, in the next video I'm going to make, we're going to talk about, now you could actually solve every single quadratic equation can be solved like this. Because you just complete the square. Now, I picked one that was kind of nice. I mean, we got a is equal to -4. A lot of times you're going to get a is like some weird number, right? Like a really tough number. But here it was just kind of nice. All right. And the next video I'm going to show you is, I'm going to have to make is maybe a tougher solution. But it's going to be a more generic solution. And it's one that's going to work for every problem a lot faster than having to complete the square every single time.